Let us start today's first lecture. I'll start with a very common problem related to counting with numbers, and a related problem which is sets. So everybody feels that there is no problem with counting. Everybody knows counting, but just stay with me and I'll show you what are the real problems. So let me start with the first example. Imagine you are interacting with a kid and you are telling him how to count. So usually what you do is that you have objects. Let's say I have this apple. I'm not using any number yet. Let's say I have this apple, and then we tell them that there are two apples. So how do you write this? You write this as two apples. Yeah? So far so good, yeah? The problem is I have to ask a question. Do I have to say this complete, like two apples? What if I just say two, because I know I'm talking about apples? So is this the same as two? Yeah? Now why am I asking this? There is a reason. Let's say you later on want to add two apples to two apples. So you say, I have two apples plus two apples. Yeah? And here it's very easy that your answer will be, most of you would say 4 apples. Yeah? That's okay. You think, there is no problem. But what if I now replace this with something else? Let's say I replace this with oranges. So now what will you do now? 2 apples plus 2 oranges. Okay? You might think that, it will give me 4 fruits. Yeah, that's okay. But here's a problem. This will not actually be very useful if I, let's say, replace this apple, for example, with 2 cars, yeah, and I still go with 2 oranges. So what will you say now? Maybe you come up with a new word, but the whole purpose of doing mathematics is to make it useful, and I don't see any usefulness in this. You can say that, I have 4 objects, so instead of writing cars, I will say 2 objects, yeah, plus 2 objects, and I have 4 objects. This may satisfy the mathematician, but I don't think it will satisfy my child, yeah. If I give him 2 tablets of medicine, yeah, and 2 chocolates, yeah, 4 what, yeah? So there is a hell of a difference for a child between 2 chocolates and 2 tablets. So this is only actually the starting point. So let's now get deep into it. Because we are dealing with kids, it is much easier to talk about these numbers when we combine them with these objects. So like if you say 2 apples, they can see apple. But what if I remove this apple and if I just say 2? So what is 2? Have you ever thought about it? What is the number 2? So that brings me to the next question. Can I replace this 2 apple with 2? Obviously not, because if I can simply get rid of this, then how would I know whether I'm counting 2 cars or 2 apples, for example? So that's not the option. Yeah? What we need to do is, okay, let me tell you one more thing. Why is it more important to distinguish this number, which as a concept, from this combined statement, yeah? Like 2 apples? Why is it important? Because later on you will multiply, yeah, you know, multiplication, you multiply numbers. So if I say 2 apples multiplied by 2 apples, what do I do with this? Or you will say, no, I will just get rid of it. 2 times 2 is 4. But what is 2 apples times 2 apples? Is it 4 apples? Or if you recall something like that, yeah? If it were, for example, meters, 2 meters, 2 meters, you know the answer will be 4 meters squared. But does it make sense to say apple squared? Yeah? Okay. So you have to, struggle to give meaning to apple squared. You can say, okay, no, this is just 4 apples, yeah, because I know what I'm doing. Many people say that. Yeah. So let's say I am happy and you are also happy with 2 apples times 2 apples equals 4 apples. Now here is the problem. If I cancel this apples and this apples, because I know I can cancel things when they multiply, then I have an apple left there. Yeah, the units, let's say if I take this as units, so number, units. This is kind of the number and this is telling me what I'm talking about, so that I can distinguish between an apple and an orange. So now, where do you have the apples? On the other side. Or you can say, okay, now it must be apple squared. So what does it mean to have apple squared? So we have some serious issues, yeah? And to spice things even further, what if I divide 2 apples by 2 apples? So is the answer just 1 or 1 apple? And if the answer is 1 apple, you see, these are real questions, yeah? And if you're not asking these questions, it's only because you have learned not to ask. You have somehow accepted the reaction of your teachers or your peers, and everybody is saying, okay, this is not a stupid question. You have to tell, if a child comes up with this question, you should be able to tell that child, and you have to convince that child. One more thing, that 2 apples times 2 apples. For example, if I simply say 2 times 2 apples, this may be easy for most of you, because I'm just saying, okay, I start with 2 apples, and this will be simply 2 apples plus 2 apples. This makes sense, and I think it will be easy for most of you. But what if I want to say 2 apples times 2? So let me, before I get to the answer, we'll get to the answer slowly. So let's crack the thought process in a human mind. You are doing many things, but psychologists have studied the human mind for a very long time, and they have cracked this process. What you actually do is not that simple, yeah? So if you have these apples, I'm not saying to, what am I actually doing? Based on experience, what I'm doing is this. I observe these apples, and I sometimes also observe, let's say, yeah, an apple, an orange. And then let's say I have flowers, yeah. So now I can see a pattern. So let's think of it as a collection of apples, a collection of oranges, a collection of flowers, and so on. Now, I have one more flower. I can easily say, even if I don't know anything, a child can easily say that, okay, these two are one kind of collections and this is a different kind of collection. Why? Because in these collections you can map, you can have a matching, a perfect matching. You match this apple with this orange, this apple with this orange. If you want to do something similar here, yeah, you can match, but this flower, okay, I'm not even saying one, this flower will be left out. So it means that you have to agree with me that these two are one kinds of collections and this is another kind of collection. And maybe if I draw a line here, I can now add a similar collection, let's say, of glasses. Oh, now I can make sense of it. I can match these things. So now I have different kinds of collections, and you can add to this many collections of this type. So why not, instead of dealing with so many different types, they all have one thing in common. Yeah, they share a property. So that number is actually not a physical thing, that's an abstract concept in the human mind to simplify these counting problems. So we have somehow invented symbols, and these symbols vary from culture to culture. You know all the history. So if I represent all these types of collections by this symbol 2, this is just the modern form of it. Maybe in the past people used different. You know Roman, yeah? How would they write it? They will write it like that, and you can come up with any other. Similarly, this one is, in the Roman you would write like that, and here you will write that. So one thing should be very clear: we must distinguish these abstract symbols from the actual collections which are represented by these symbols. But there is more to it. Actually, when I draw these symbols on a whiteboard, I could actually bring actual apples and actual oranges, but that will be impractical. Yeah, I sometimes want to imagine things, and then I have to imagine an apple. So I have a sketch of it. So this thing which I have on this board is not an actual apple. It is actually another concept, another abstraction of the actual apple. So let me now summarize all this process, what you are doing when you are counting. Yeah. So basically we are dealing with 3 different words. Yeah. Although I will be representing that by symbols, but you know what I'm meaning. Here I will be dealing with the real world, things as they are in reality, yeah, which I'm observing. Here I have, actually there are 2 levels of abstractions. First we simplify things in the first step, and then we simplify it even further. So that first step, you can give it a name, the conceptual world. Yeah. And then that third symbolic word where we use simply symbols, and I can simply call it the mathematical word. So now let's get back to this counting. What I do here in the real world with a few apples. And similarly, here I can start with a few flowers, and say here I start with a few glasses. And for shortage of time, I'm only giving 2 examples. You can imagine many examples, and you can imagine many examples. Maybe I give one more example here, and that is let's say 2 forks, yeah? 2 fork, sorry, no, not 2 forks, yeah? And I have selected these examples in such a way that I can have this matching, yeah? One-to-one matching, one-to-one matching. Now when I observe this, and when I also know that, okay, I am only interested in counting, that helps me to have a simplified conceptual view of this. Yeah? So instead of looking at the actual apples, I have here in my mind a conceptual collection, and that collection can be much simpler. I can simply write, for example, A, comma A. A represents this apple, A represents this apple, just because this is all mental. And here I can have flower, yeah, and I have that, yeah, matching here as well. And then I have, let's say G. You can come up with any other way, yeah. So symbolism always represents abstraction, which simply says that, okay, you're not dealing with real things, but with abstract things. Oh, they do represent the real things, and say this is, yeah. For example, if there were spoons, yeah. So spoon. Okay. They do represent the real world because they capture the property we are interested in, and we are interested in counting, and they are good enough for counting. So I don't care about, yeah, the other properties like weight or color or shape or, yeah, the fact that this may be more expensive than that and so on. So what do I do here is that because I recognize this as one kind of collection, yeah, belongs to one kind of collection, this belongs to the same kind of collection. So for all these types of collections where I can match any of the two collections, so one collection can be matched perfectly with any other collection in that class of collections, I represent all of that by just one symbol, yeah. But here is the deal. Okay, let's say I use this symbol 2, yeah, and here I also write 2. But now, if this is 2, there is a problem. I need to distinguish apples from, for example, flowers. So they do share this property, but I need to specify that I am here dealing with 2 apples, and here I am dealing with 2 flowers. Now I can say, I can comment on the difference between this number, which is abstract, and this thing, which is also abstract. Now, this thing, you can think of it as a quantity, yeah, because apples make sure that you are talking about 2 apples, not just 2. So which means that this number is the same as this number, yeah, but this quantity of 2 apples is not the same as this quantity of 2 apples. You have 2 different quantities. That is why you can call it a unit. An apple serves the purpose of a unit. So I have one quantity here, a quantity of apples, and here I have a quantity of flowers. So here I will have 3 glasses and 3 spoons. Yeah, a quantity of glasses, a quantity of spoons. Now, what do these 2 quantities have in common? They differ by their units, because apple is not the same as flower, but they share one property, and that is this number 2. What does this number 2 represent? So we need different names, yeah? Everybody uses quantity. When you say quantity, you know that you have to actually specify the type of object. And if I do not concern myself with that, and if I only focus on this number, there is another name for that, and that is count. So this 2 is the count. So I can say that these 2 quantities have the same count. Yeah, these two quantities have the same count. Count has no units. Count is purely abstract. We have to close now this session, but let me just tell you one thing. For the next lecture, we are not yet done with this discussion. Yeah, so there is more to this number than we have covered so far. So far, you see this just as a magical symbol, but we need to give it a more deeper meaning. Yeah? A meaning that is much, much deeper than a count. And one more thing is that you have heard this quantity in different contexts, so just we need to make sure that this quantity is just one kind of a quantity where we are interested only in the count. There is another kind of quantity which I will discuss in the next lecture. For example, if I am interested in the weight of it, how large or how heavy or how costly. Yeah? So there maybe I have to introduce you to another kind of quantity. That quantity will have another unit, and maybe you need a different kind of number there. So stay tuned, and we'll actually make it more and more interesting in future, inshallah. Bye.